Welcome back to Matt Explains Science. Today our class will be looking at the golden rules for using significant figures. So let's get straight into it. So what exactly are significant figures? Well, they are an indication of the margin of error in a measurement, and they are the number of digits in a measured quantity with meaning. The last digit is always considered uncertain. So, for example, a graduated cylinder with 1 millimeter graduations contains 5 milliliters of water. This means that the water lies between 4 and 6 milliliters. We can say that the cylinder contains 5 milliliters plus or minus 1 milliliter and is accurate to one significant figure. Now a second cylinder with 0.1 milliliter graduations again contains 5 milliliters. Now we can see that the water line lies between 4.9 and 5.1 milliliters. So we can say that the cylinder contains 5.0 plus or minus 0.1 milliliter and is accurate to two significant figures. Now, there are some golden rules that can help us determine how many significant figures to consider. Firstly, any non-zero digit is significant. Take for example the height of the Empire State Building at 443 meters. Because all three digits are non-zero digits, we can confirm that there are three significant figures. Another example, the current world record for the 200 meter sprint is set at 19.19 seconds. Here we have four significant figures as all digits are non-zero. Rule number 2, zeros between non-zero digits are significant. For example, the Rio Grande River that borders the US and Mexico runs 3,051 kilometers. This also has four significant figures as the zero is between non-zero digits. Rule number 3. Zeros to the left of the first non-zero digit are not significant. For example, a single grain of salt has a diameter of 0.03 centimeters. In this example, the first two zeros do not count as significant figures, only the final digit. Again, the size of a hydrogen atom, the first 8 zeros are not considered significant. Only the last digit is considered significant. Both of these numbers have just one significant figure. Rule number 4. For numbers greater than 1, all zeros to the right of the decimal point are significant. Consider the height of two children, Trevor and Sally. Trevor has a height of 1.105 meters and Sally 1.020 meters. Because these are numbers greater than 1, the zeros to the right of the decimal are significant, so for Trevor, 1.105 is 4 significant figures, and for Sally, a height of 1.020 is also 4 significant figures. Rule number 5. For numbers less than 1, only zeros at the end of the number or between non-zero digits are significant. Take for example the thickness of copper flashing at 0.0270 inches. The first two zeros are not significant, but the zero at the end is significant. Therefore, we have three significant figures. And rule number 6, trailing zeros in whole numbers may or may not be significant. For example, the Little Belt suspension bridge in Denmark has a length of 600 meters. Because of the trailing zeros, we are not sure if this means the bridge is really 6 meters with one significant figure, 60 meters with two significant figures, or 600 meters with three significant figures. To avoid such ambiguity, we can use scientific notation to indicate correctly the number of significant figures. So 600 meters can be written as 6.00 times 10 to the power of 2 meters, whereby the three digits are all significant. So, to summarize, any non-zero digit is significant. Zeros between non-zero digits are also significant. Zeros to the left of the first non-zero digit are not significant. For numbers greater than 1, all zeros to the right of the decimal are significant. But for numbers less than 1, only zeros at the end of the number and between non-zero digits are significant. And finally, trailing zeros in whole numbers may or may not be significant. Okay, so to finish, there are a few more rules we need to be aware of when making calculations with significant figures. So let's take a look. Firstly, when adding and subtracting numbers, the answer cannot have more digits to the right of the decimal point than the original numbers. For example, 42.164 plus 3.70. Bear in mind that the first number has 5 significant figures and the second has 3. So let's just add them together quickly. And the answer we get is 45.864. So as I said, the answer cannot have more significant figures than either of the original numbers. So 45.864 can only have 3 significant figures. So here we must round up to 45.9. Another example, 1.112, which has 4 significant figures, minus 0.93, which has 2 significant figures. So let me just resolve this for you again. So there you go. 1.112 minus 0.93 gives us 0.182. Again, bearing in mind that the answer may only contain 2 significant figures, here we must round down to 0.18. Right. Rule number 2, when multiplying and dividing, the number of significant figures in the answer is determined by the original number with the smallest number of significant figures. Take for example 1.24 times 2.6. So here we can do a little trick to help with multiplying. We just times the top by 100 and the bottom by 10. And we can work with 124 times 26. So starting with the 6 at the bottom, we multiply by 4. This gives us 24. So we put the 4 in the units column and then carry the 2. Then 6 times 2 is 12. The 2 we add to the other 2 carried over to give us 4 in the tens column, and then carry the 1. And finally 6 times 1 is 6, and then add the 1 to give us 7 in the hundreds column. Now we do the same for the number 2, remembering that the 2 represents 20. So we put 0 in the units column, and then 2 times 4 is 8, sorry. And then 2 times 2 is 4. And finally 2 times 1 is 2. Right, the last step is to add 744 to 2480. Let's just do this quickly. Yes, and this gives us a total of 3224. Finally, we have to remember that the original number multiplied by 1000 to simplify calculations. So now we just divide by 1000, get the original answer. And this gives us 3.224. Now, as the original number 2.6 had only 2 significant figures, the answer 2 must only have 2 significant figures. Therefore, we round down to 3.2. Right, finally, rule number 3 is that exact numbers, such as counted objects and mathematical definitions like pi and the gravitational constant, have an infinite number of significant figures. Okay, take for example a pencil. This standard pencil has a mass of 0.0125 pounds. Now, if we were to have 8 pencils, we simply multiply 0.0125, which has 3 significant figures, by the number 8, which is an exact number. So we assume it has an infinite number of significant figures. Because we need to consider the number with the lowest amount of significant figures, the answer may only contain 3. So 0.0125 times 8 gives us an answer of 0.100, which is 3 significant figures. So to summarize, when adding and subtracting, the answer cannot have more digits to the right of the decimal point than the original numbers. When multiplying and dividing, the number of significant figures in the answer is determined by the original number with the smallest number of significant figures. And exact numbers, such as mathematical constants and counted objects, have an infinite number of significant figures. Well, that's it for today on Significant Figures. I hope this has helped. Thanks again for watching, and stay tuned for more content. Please like and subscribe. Thank you very much.